In this video, I'm going to review a new feature in the performance verification module. This is for versions of DoseControl version 2 and higher. And we have two PV test methods that you're able to configure. So first you need to log into the software using your app admin user role. Go to the box with the check mark and you'll see the configuration settings button. Down here, you can add a PV test configuration. Click that. And here are the two options. So the top one, and I'll show this on the screen in a minute. The first one is a basic PV method, exactly the same as earlier versions, where you are testing a single photometric reference standard at one wavelength. And the next option here is you're testing a single photometric reference standard, but you're bracketing the wavelength of use. So you'll be testing at two wavelengths. So let me show you how these look. On this first one, this is using the basic PV test method. And as you can see, we're collecting a lot more information than in the previous version. For here, you will give step one will be to give your PV test method a name. So this would be something that your users can easily identify. So I've called mine a daily PV test. You can say daily test of evolution device ID 008 or whatever you use internally. You can set a frequency. So this would set a timer in the software. So if you enter 24 every 24 hours, the software will prompt the user to perform a PV test. I've left mine blank because I want to do this test on demand. Step two is you will choose your reader type. So this is important. So we have two models of the evolution. This is the thermo evolution spectrophotometer. The evolution 1 plus for all absorbance values under 2 absorbance units. This is their written photometric accuracy specification. It's 0.004. And the evolution 220 for everything under 2 absorbance units is 0.006. So make sure you select the correct reader model that you use. And step 3, you want to enter your reference standard kit information. And so this line right here, we're having you enter the serial number of your reference standard kit, a description. So again, you may have your kit labeled with an internal device ID number. Enter in the manufacturer, which would be, we're using the Thermospectronics Standards Kit 2. So you enter in that model number and the calibration certificate number. So you're basically taking all the information from your standards kit calibration cert and entering it right here in the software. And this is important because the PV test is now traceable to a specific calibration cert number. And as you remember, these reference standards kits need to be recalibrated every 2 years. Step 4, you enter the certified values for the physical photometric standard. So this is that glass standard in the kit. They are labeled with an exact ID. So you enter this right here. You enter a description, this is what will appear on screen for your user, so something that they can easily identify. And from your calibration cert, you enter the nominal absorbance, the testing wavelength, the certified absorbance at that testing wavelength, and the uncertainty for the standard. So as you can see below, the software is now doing the calculation for you. So for this photometric accuracy test, it calculates the test parameters. So this is taking the combined uncertainty of the standard itself plus the standard of the reader, and plus or minus from this certified absorbance specification. So it's the exact same calculation as all our previous versions of this performance verification module. The only difference here is instead of having you do the math, we're letting the software do this, and it just reduces configuration errors. So step 5, as you can see, is this. It just talks about the wavelength accuracy test. So just as before in previous versions, it's hard-coded. You don't need to configure anything. I've spelled out the wavelength accuracy specification because we're using that internal xenon lamp of the evolution. So if you look down here in the overview or the summary, it gives a summary of the test details and the test parameters. So again, this is just hard-coded. You don't need to configure anything. And it also will provide an overview of all the information that will appear in your PV test report. So this is the printed PDF report, so you'll be able to see what standard kit ID you're using, all the descriptions. So this is our basic configuration. Again, it's exactly the same. It functions exactly the same as our previous versions. It's just a different screen, and we're collecting more information about the calibration certificate. And also the software is doing the math for you to set the test parameters. So next I'm going to show you what the second method is. If you remember, this is the bracket wavelength of use. So if I go in here and I want to choose this one, this is what this test setup will look like. It's the same screen, and it'll be more or less the same workflow in the software for the user. The difference here is you go down to step 4, and you'll see for that standard, that's that physical glass reference standard, you're going to be entering in 2 testing wavelengths. So again, the use case here is sometimes people, so for B3 dosimetry, you're always measuring at 552. Well, there's no such thing as a photometric reference standard at 552. So what people want to do is they can test slightly below and slightly above that application wavelength. So off of your calibration certificate, for the photometric standard testing wavelength, you can choose 465 nanometers. Here's the certified absorbance specification at that wavelength. And then you can also choose 590, which is above your application wavelength. So your testing wavelength, 590 nanometers, and enter in the certified absorbance specification at that wavelength. So you're good to go. And again, you look down here at the overview, you can see it has 2 photometric accuracy tests. So for test 1, here's the test parameters, and that's that right here, the 465 test parameters, and accuracy test 2 is at that 590. So again, the software is doing the math for you. So that is the bracket wavelength of use test method. For this, you want to make sure you also label your method ID, something that your users will quickly understand that they're doing a bracketing test. So I put PV test at 465, 590. And then going back to my main screen, you can see I've got both of my tests active in the system, and I have my bracketing test as the default. Click Save, and you're done.